Miss Hotel. We are the Group 6 and for today's lesson, we will discuss about the topic of quartile per group data. But hey, stop there and focus. Because we will be asking questions later, so be sure to listen and, if possible, list down all the important details, okay?
What is quartile? A quartile is a statistical term that describes a division of observation into 4 defined intervals based on the values of the data and how they compare to the entire set of observation. First quartile is 25% from smallest to largest of numbers, while second quartile is between 25.1% and 50% to median. The third quartile is 51% to 75% above the median. And lastly, the fourth quartile is at least 25% of largest numbers.
What is group data?
Group data are the data formed by aggregating individual observations of a variable into groups, so that a frequency distribution of this group serves as a convenient means of summarizing or analyzing the data. Now that we know those words, it's time to go to our next topic, quartile for group data. Kisha, can you explain?
Quartiles are values that split up a dataset into 4 equal parts. For this topic, we will use the formula QK is equals to LB plus KN over 4 minus CFB over FQK times I, wherein Q is for quartile, K is for the quartile as in the given, for example, Q1, Q2, Q3, and Q4. CFB stands for cumulative frequency before, F is for our frequency, I is for interval or the numbers from first to last. Now, let's try to fill up this data set or chart. Usually, they only give the interval and the frequency, so we will be needing to solve for LB, CB, and for our quartile. In this data set, we have a class interval or the probability of the scores that the students got, which is 11 to 15, 16 to 20, 21 to 25, 26 to 30, 31 to 35, and lastly, 36 to 40. To get the interval, we will have to identify what is the number added from the previous one. For example, 11 to 15. We'll just have to count from 11 to 15, like 11, 12, 13, 14, 15. And our interval is 5. Our I is 5, so I is equals to 5. We also have here the frequency or the students who got the score from 11 to 40, in which we have here 3, 12, 8, 15, 9, and 3. How do we get the end though? Well, we'll just have to add the frequency, like 3 plus 12 plus 8 plus 15 plus 9 plus 3. Then we will get 50. So our n is 50, or n is equals to 50. Now, here is Mr. Kaligang to solve for lower boundary.
Thank you, Ms. Gallardo. Just that you'll get the number in between the last number from the last set of interval and the first number from the previous one. For example, we have 11 to 15 and 16 to 20. The last number from the last set is 15 and the first number in the previous one is 16. So all we have to do is to get the number between them, which is 15.5. Right? And yes, it has condition. You always have to put it in the higher set, so between 11 to 15 and 16 to 20. The higher set is 16 to 20. Okay, now that I've explained it, it will be a lot of easier for us, right? Well done, we got them. Oh, so have here 10.5, 15.5, 20.5, 25.5, 30.5, and 35.5. Now we're done. Let's move on to the cumulative frequency. Can you explain it to us, Mr. Santos?
Sure thing, Mr. Kaligang. And now, I'm here to let you guys know how we will find which is the cumulative frequency before. Oh no, how we're going to get it if we were missing the highest cumulative frequency? For that, we'll get the n, which is the total number of the frequency, and place it in our highest CFB, which is the cumulative frequency before. And what is it again? Oh, it's 50. So now that we get the highest cumulative frequency, let's get started. As I said earlier, to get the CF or the cumulative frequency, we need to subtract the frequency we get from the highest cumulative frequency, which is the 50. And the frequency that we need to subtract to the highest cumulative frequency are 3, 9, 15, 3, and 12. And this is how we're gonna do it. 50 minus 3 is equal to 47. 47 minus 9 is equal to 38. 38 minus 15 is equal to 23. And 23 minus 8 is equal to 15. And lastly, 15 minus 12 is equal to 3. And that's the step you should do in getting the CF or the cumulative frequency for your table.
Let us first get our quartile 1 and substitute all the given. So we have here QK is equals to LB plus QN over 4 minus CFB over FQK times I. But before that, let us get our KN over 4 so we could get our F, LB, and CFB. Since K is 1 and our F is 50, so 1 times 50 is equals to 50 over 4, then it will be 12.5. Now that we've got our Kn over 4, we can now go back to the data set and get our F, LB, and CFB. All we have to do is to focus on CF, which we can see that 12.5 is between 15 and 3. But we'll get it from the higher row. So in this row, we can see our F is equals to 12, LB is equals to 15.5. But since we're getting cumulative frequency before, then we got 3 instead of 15. Now, let's substitute our given and solve. So QK is equals to Q1, LB is equals to 15.5, Kn over 4 is equals to 12.5, CFB is equals to 3, F is equals to 12, and I is equals to 5. So 12.5 minus 3 is equals to 9.5. 9.5 over 12 is equals to 0.79. 0.79 times 5 is equals to 3.95. And lastly, 15.5 plus 3.5 is equals to 19.45. So our quartile 1 is 19.45, or it can be 20. So therefore, 25% of the students have a score less than or equal to 20.
Now, let's move for our second quartile. For our second quartile, we're gonna do the same Keisha did in first quartile. And also the formula she used, which is the QK equals to LB plus quantity Kn over 4 minus CFB over FQK times I. But first, let us get our Kn over 4. So, we will get our frequency, lower boundary, and cumulative frequency. Now, this is the solving process in getting our Kn over 4. Kn over 4 is equal to 2 times 50, which is the total frequency before over 4. 2 times 15 is 100. Divided by 4 equals to 25. Now that we got our kn over 4, we can now go back to the dataset and get our frequency, lower boundary, and cumulative frequency before. All we have to do is to focus on cumulative frequency, which we can see that 25 is between by 38 and 23, but we'll get it from the higher row. So in this row, we can see that our frequency is equal to 50 and our boundary is equal to 25.5. But since we're getting the cumulative frequency before, then we got 23 instead of 38. Now, let's substitute our given and solve. Now, we're getting our second quartile. And this is the process or solving we're gonna do. Q2 equal to 25.5 plus quantity 25 minus 23 over 15 times 5. 25 minus 23 is equal to 2. Now, we get it. We're gonna apply it to our formula, which will be Q2 equal to 25.5 plus quantity 2 over 15 times 5. Now, our next step thing to do is to divide 2 to 15. So, we could get 0.13 and apply it again to our formula. And it will be Q2 equal to 25.5 plus quantity 0.30 times 5. Now, our 0.30 will be multiplied by 5 and the answer is 0.67. So we could apply again the formula in this situation. Q2 equal to 25.5 plus quantity 0.67. And now, our last thing to do is to add 25.5 to 0.67 and we could get 26.17. And that's for our quartile 2. Now that we got 26.17, therefore 50% of the student have a score less than or equal to 26.17.
How to get the quartile 3? First, we need to find the Q3 class by computing Kn over 4. Then, substitute the K to 3 and N to 50. Then, 50 times 3 equals 150 and divide it to 4. So, our Kn over 4 or Q3 class is 37.5. So now, our n is 50 and our class interval is 5. So now, we just need to look to Q3 class. So the 37.5 is between the 23 and 38. So, meaning to say, we're going to get it in 26 to 30 class interval. And now, our lower boundary is 25.5 and our cumulative frequency before is equals to 23 and our frequency is equals to 15. And using the given, we would calculate it using the formula. Q3 equals lower boundary, which is 25.5 plus Kn over 4, which is the 37.5 minus cumulative frequency, which is 23 divided 15, which is the frequency, and our interval is 5. So we need to subtract 37.5 minus 23 equals 14.5. Then we should divide, which is 14.5 divided 15 equals 0.97. And we would multiply 0.97 times 5, which is equals to 4.85. Then we will add it. 25.5 plus 4.85 equals 30.35. And that's all.